Welcome, and thank you for joining this webinar, Wireless Driving the Automotive Machine to Platform Transformation, prepared by Alpert Research Team. Today, we're exploring one of the most profound shifts happening in the automotive world, the transformation of vehicles from mechanical machines into intelligent, software-defined platforms powered by wireless technology. Now, let's pivot specifically to EVs. You mentioned wireless battery management systems, wBMS, as a major shift. Can you elaborate on why that's such a big deal?
It's arguably one of the most radical wireless-enabled changes in vehicle design. Think about a typical EV battery pack. It can have hundreds, even thousands of individual cells. Each one needs to be monitored constantly for voltage, temperature, state of charge.
And traditionally, that meant wires to every single module.
Miles of copper wiring harness snaking through the battery pack. It's heavy, complex, expensive to manufacture, and takes up valuable space. wBMS replaces up to 90% of that wiring. Each battery module communicates wirelessly with a central controller. It can cut 10 to 20 kilograms of weight per car, which helps with range, and it frees up maybe 15% of the pack volume.
Which means you could fit more active battery cells in the same space.
Exactly. More energy density, potentially more range, or a smaller pack for the same range. But and this is a critical point highlighted by the Alpert Research Team's work, this shift comes with a massive validation challenge because the battery is so critical to vehicle operation and safety.
Potential fire hazard if it goes wrong.
Precisely. The wBMS must achieve the absolute highest level of functional safety certification under the ISO 26262 standard. That's ACE-LD.
We hear ACE-LD mentioned a lot with critical systems. Can you explain briefly what achieving ACE-LD means, especially for a wireless system replacing a wire?
ACE-L stands for Automotive Safety Integrity Level, and D is the highest, most stringent level. It's reserved for systems where a failure could lead to severe injury or death, think braking, steering, or in this case, a catastrophic battery failure or uncontrolled thermal event. Getting ACE-LD certification for a wireless link is incredibly tough, because you have to prove with extremely high confidence that the wireless link is as reliable or even more reliable than the physical wire it's replacing. We're talking about demonstrating reliability levels like 99.999% availability and system failure rates below 1 in 100 million hours of operation. It demands rigorous design, fault detection, redundancy, and extensive testing, usually validated by independent third-party organizations like 2SEAT. It's a huge engineering effort.
The other big EV-specific application is wireless power transfer, WPT, or wireless charging.
WPT is about convenience, getting rid of the charging cable. The main standard driving this is SAE J2954. It ensures that different cars and charging pads can work together. Right now, the focus is mostly on stationary charging. You park over a pad in your garage or a parking spot, and it charges typically up to around 11 kilowatts. They're achieving pretty good energy efficiencies too, maybe 93%.
So convenience mainly for now.
Convenience and less wear and tear on physical connectors. But the really exciting future for WPT is dynamic charging while driving.
Great.
So what does this all mean? The message is clear. Wireless is no longer an add-on. It is the infrastructure of modern automotive value. If you take away one thing from this review, let it be this. Wireless is now the central nervous system of the automotive industry, and mastering it is essential to driving the future of mobility. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert Research Team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.